It's working.
Thanks.
Welcome to the M3 Live teardown of the Breville Sous Chef food processor. M3 Design is a product development firm that crafts and executes product development strategies for technology-leading companies. As part of our process, we perform product heuristic evaluation and product teardowns, some of which you can see on our website. If you look there at www.m3design.com, you'll see actually the heuristic evaluation that we did of this product that we're about to tear down. Heuristic evaluations is a means that we use for our product development team on a regular basis to identify potential usability problems and to understand how a product behaves and communicates to the user. From this, we score and rank products on how well this is designed for the ideal user experience. Product teardowns are a way for us to look at how other people have identified and solved for unique design challenges. Part of it is to understand the why behind how the product was designed. For instance, why did a product designer design the product in the way it was? Why did they choose certain materials, processes, and why did they incorporate certain features while they went ahead and omitted others? I will now introduce Coleman Horton, one of our mechanical engineers at M3 Design, who will take you through the product teardown of this Breville Sous food processor.
Okay. Hello, everybody. Thanks, John. Like you said, I'm Coleman, and I'm going to tear down this Breville food processor. Real quick, one of the reasons we decided to tear this product down is there are a few interesting features that we wanted to look into. One is that this thing really operates in a messy environment, and we wanted to see how the original designers did fluid management and how they prevented messy debris and other liquids from getting inside the internals of this space where the motor lives. And they're sort of the two primary questions we wanted to answer when we tore this down, or when we tear it down today, is one, how the internals are protected, and two, we wanted to see how this housing of the base was manufactured, because it looks really nice and we're curious how they made it cost effective to make. So we'll investigate that as we take it apart. Just a real quick overview. These are all the attachments that come with this device. Most of these are single piece, or it's just a piece of metal overmolded with plastic. So we're not going to do really any teardown stuff with this, but I'm just pointing out all these attachments come with the device. Overall, this device seems impressive, but this isn't a review. This is a teardown, so we can get into it. There are a few basic components to this whole system. We have the base, obviously, and then I'll call it the bowl, this clear plastic bowl that you put stuff into. There's a little mini bowl that you can use with some of the smaller blades, I guess, if you have a smaller volume of stuff you want to process. And then the lid that goes on top of the bowl. I think I'll take apart the base first, and then we'll come back to the shaft and some of the other mechanisms inside the bowl. Okay, so see the cord comes out the back. There's a length of cord that you can store in the back here. We'll just start by taking it apart. All the fasteners, it looks like, are on the bottom. Screwdriver here. So the first thing I noticed is that there are 4 rubber feet. And what's interesting is, if I can get the camera to see it, there are these little plastic retainers inside each rubber foot. And it seems like a very clever way to keep the rubber foot anchored to the base housing itself. Something I've noticed just from being a product designer and enjoying gear in general is that rubber feet tend to like to fall off, like the rubber feet on my PC at home. they fall off all the time just because they're stuck on with adhesive. So it seems like what the Breville designers did was clamp on the rubber feet with these plastic retainers as a way to prevent them from falling off. And I haven't used this product enough to know if that was successful, but it seems like a good idea. Right. So these rubber feet just pop right out. Show you here. Here's the little plastic retainer that was holding down this rubber foot here. And it's hard to tell, but I'm curious if they used identical feet. Nope. All these feet are unique shape. So you can't put the wrong foot in the wrong spot. And that's interesting because it seems like with just a slight minor tweak of the shape, the designers could have used the same foot in multiple locations, but they decided not to. And this is a good example of where the function is actually following the form. They decided to go ahead and make unique shaped feet so that they could get the exact shape that they wanted, which is interesting. All right, I'll put these feet off to the side. All right, so now there's just a handful of screws recessed down in some bosses that I'm gonna take apart, take off. I think that's all of them. Let's see. Oh, it wants to come free. There we go. Okay. I'll set this bottom cover off to the side. So we can see immediately that the majority of the volume in here is taken up by this large motor. I can already look down in there and see that the motor is actually mounted on some rubber grommets for vibration and probably noise isolation, so that the vibration of the motor isn't going to be transmitted directly into the housing. Speaking of the housing, since that was one of the main questions we want to look into, I can tell already just looking at it, it looks like it's a die cast part. I can see some ejector pin marks down in here, and a lot of trying to get the light in here so the camera can see, the screw bosses are part of the cast metal. It's probably just a stainless, and the screw bosses have these triangular shaped holes so that thread forming screws, self-tapping screws, can just be screwed directly into these bosses. So that's really interesting. It's the coating on the outside of this thing actually feels almost plastic. It doesn't have the same like coolness that metal typically does, but it still looks like brushed aluminum. So I think it's interesting that it is metal, then it was coated to feel like plastic, even though it still looks like metal. But all right, let's see what else we got in here. Obviously, a lot of the main electronics up here at the front. Let's take apart this. This is this rear tray. So we're gonna move it so the light can catch it. This is the tray that the cable actually slides into. So you can just push the cable in, and it just kind of piles itself up inside this pocket back here. Okay. Well, I can see a couple screws down here at the bottom of this plastic tray that I'll take out. It seems to be in the way of getting the motor out. I'm glad I planned ahead and brought this long screwdriver, because the screw is really buried down in here. There we go. This thing's kind of wedged in a little bit. Oh, I see what's going on. So there's actually a retainer that's holding where the power cable comes in, and it's preventing me from pulling this plastic housing out. I'll unscrew these 2 screws on this little retainer right down in here. Sorry, it's hard for me to hold this so the camera can see it and use both hands to manipulate the screwdriver at the same time. So I'm going to kind of be back and forth between doing the things and then pointing out the features. All right, so here's this little retainer that was just holding the power cable down. Now, okay, now I can take this plastic tray out. The cable over here. Drag. Okay. So here you can get a better view of what's going on inside. Just looks like 3 mounting screw locations for the motor itself. And I'm trying to think what I should take off first. Let's go ahead and take the motor out if we can. Before I do that, I changed my mind. Let's take all the PCBs out instead. Actually, before I do, this is interesting. This is it just came right out. This is a plastic tube, and this might be really difficult to see where it's coming from with the lighting, but I'll point it out once I get the motor out and you can see it better. But it looks like this tube is actually connected to the drain line. Something I forgot to mention before I took the bottom off was really the 2 mechanical interfaces up here on the top of this base are the motor interface, where the shaft and the bowl connects to the motor drive. And then the other one is this mechanical switch. And I know it's a mechanical switch because I can see it. And if I get something skinny, I can push on it and move. And this is a lockout so that the motor won't turn on unless the bowl is locked into place. It's a safety to prevent this shaft, this interface from spinning without a bowl on it. And also because of the mechanism in the bowl itself, you can't turn on the motor and the blade without having the lid on top of this bowl either. So the reason I brought that up is it looks like this plastic tube is connected directly to where that little mechanical switch is on the top surface. I'll take a few more parts out and then maybe we can get a better look. Okay, let's see. So this PCB was just slid into place in some retaining slots over here on the side. And then there is a, oh, I see. So there's just a little spring post pin up here that I need to compress. Some pliers in order to get this PCB off. Okay. Now the lengths on all these cables might prevent me from pulling these things out one at a time. They probably all went in a very specific order. So it's about as far as I can pull this guy out. I will start taking off some other components. It looks like there's a transformer in here that I'm about to take out. This guy right here. And it's like on a serious seriously flexible rubber mount. It's interesting that this part is really isolated, and it's on a very flexible rubber vibration isolation mount. Looks like I need to take it out next. One screw. Okay, here it is. And this is that. I'm not an electrical engineer, but this looks like some sort of transformer to me. And you can see this very flexible rubber mount. Apparently that component is sensitive to vibration. All right, let's get this plastic tube out of the way. I'll put him back in later. So this giant starter capacitor over here is an AC starter capacitor, probably to get this motor kick-started when you hit the on button. It seems to be the next component that needs to come out. Slightly smaller screwdriver. Okay, so nothing too exciting here. Big starter capacitor. I'm going to go ahead and unplug this from the board with these spade connectors, just to kind of get it out of my way. All right, there we go. Set him off to the side. All right, let's see what's next. So we have this other big capacitor down in here, which scares me a little bit, but I'll be careful. And I think the cables on it are going to prevent me from, getting this board out. Yeah, it seems like it. I apologize for this being the boring part. It's kind of like I have to get a lot of these electronic components out of the way before I can get to some of the seals and fluid interfaces. At least that's one of the main reason I wanted to look at this product. All right, so I'm going to undo this connector that's going to that mechanical switch up there. Okay, it's just on some header pins. And then it looks like there's one final grounding screw that grounds into the, let's see it down up in there. It grounds the motor and the power input cable to the housing, the steel housing itself. All right, it looks like I now can hopefully get this motor out. Maybe not. I'll take out this drip pan assembly that I was mentioning earlier. I think it might actually be in the way getting the motor out. Right, just a couple screws on it. Okay, so here we go. This is that mechanical switch assembly that I was talking about when it was flipped over on the top. So this is that little finger that the another little finger on the bowl actually presses down to tell the control module that the motor can turn on. Since I have this in hand, I'll go ahead and pop this open to see what's inside of here, what kind of switch they got. Go. Okay. All right, so it appears to be just a simple mechanical switch right here. And when this finger gets pushed down, there's just a little ramp. So I'm trying to get the light on it. There we go. So there's just a little ramp to press that button on the switch. What I find fascinating about this is you can see on the top, there's a little, like, this is a little bit of a rubber seal around this button. It looks like a kind of a little skirt to guide any fluid that gets into the hole. I mean, this finger passes directly through a hole in the top housing. So the original designers had to be concerned about what was going to get into that hole and how was it, you know, what was going to happen if it got on the internal components. And so it seems like they designed a way to manage that fluid, and that skirt, which will then direct any fluids into this pan, this drip pan around this mechanical finger, which then drain into this hole. You can see it. This hole right here, which had this plastic tube connected directly to it. So rather than preventing any fluids from getting inside, they just decided to direct where those fluids could go. And I'm sure they had a good reason for, you know, using a mechanical switch rather than some sort of like a magnetic hall sensor or something. It may have to do with the case that maybe this is more reliable, or, you know, there are so many conditions that can cause this switch to not be pushed down. Like if you take off the lid, or take off the whole bowl, or you take off just the little hopper plunger on the bowl, all of those actions will make this pop up, and maybe they could get this function a little bit easier with a mechanical switch rather than something electrical. I'm not sure, but I find it really interesting that this is how they manage the fluid around that open hole in the housing. All right, step that off to the side. Okay, now I think we can address the motor itself. Turn this. So the motor is connected directly to this interface up here. So I'm going to need to, it looks like the whole housing is sandwiched between the interface and the motor itself. So I think I need to get this top interface piece off of the motor so I can get the motor out the back. Looks to me like there's just a little cover on top of the center post that I might be able to pry up. I've seen little, really just sort of press fit covers like this on devices before. Yep, it's coming up. Ah, there we go. Okay, so there's just a little press fit plastic cover on top of this screw inside this motor interface, and there was no adhesive or anything. So there might be an O-ring underneath the screw. I'm just thinking if fluid filled, like water, soup, or whatever, filled up this cavity, what's going to prevent it from getting down through this screw hole? And let's take off the screw and see if there's an O-ring on it or something. Okay, so if I try and turn the screw, it's going to just turn the whole motor. You can see, so I got to hold the shaft on the back side too. So I'm going to go back to the motor shaft and turn the screw. Okay, so it's actually reverse threaded. I tried it right-hand rule first, and it was tight, so I turned it to the right to try and tighten it in normal operation, but that actually loosened it here. And that's kind of common on motors, so that when they're on, they don't unscrew the screw. Okay, be careful. It's not going to fall out. So down in here, you can see this sort of shaft with flats on it is the shaft coming directly out of the motor. It's like there's a little rubber gasket tucked in around, and we'll check that out when we take the motor out. But let's take a look at this interface. I'm curious if there's a seal on the bottom of this screw. No, there's no O-ring on the bottom of it. It's just a normal screw. Oh, it's left-handed. Yeah, and there's nothing in here. So maybe that press fit on that little cap that was on here was enough to keep fluid from going in. If there was enough interference, it was pretty easy to pull out. So I'm a little dubious about that, but we'll just say that's the case. Something else is interesting is that, they have a big motor, obviously, and he's put out a lot of torque. I mean, it's turning some big blades on this device. It's sort of surprising that they decided to go with plastic teeth for the interface here. It obviously worked out okay, but I'm sure that the original designers had to run some analysis to make sure that these features would survive the torque that this motor was going to be putting out. And these teeth are pretty big and well spread out, so that will help them survive the torque necessary. Trying to get the glare on it. It's hard with these black components. They're in there. Okay. Looks like these pads, these I think are just interface pads for the bowl. We'll get to those later. My eye, I just caught my eye. Yeah. All right. Looks like these are just sort of friction pads for when the bowl gets put down on it. The plastic rim on the bowl itself will slide on these so that they can control the friction. But we can talk about that again once we get over to the bowl. All right, now, I know I've said it a bunch of times, but now I really think I can take the motor out. Take out these 3 screws that are through these rubber grommets. Okay, yeah. And I can already tell you by the weight of this thing that this is the majority of the weight inside of this entire base. That thing is hefty. And there's no gearbox on top of it. So whatever torque they decided they needed to turn the blades on this thing, they're getting directly out of this motor, which is probably why it's so big. They could have used a smaller motor and put some sort of gearbox on it to get the torque they needed, but they decided not to. And some maybe because they needed a certain amount of weight in this base anyway to prevent it from shaking around on the table. So might as well go with a big motor rather than have to add other artificial weight. And it's also probably cheaper to just go with a motor like this rather than get another secondary gearbox. So down inside the housing, you can see these 4 mount points where the little friction pads on the top, they're all the screws I dropped. These friction pads are attached. And then it looks like there is, here's the little rubber gasket that actually fits right on top of the motor. So this looks like a sort of secondary seal, and it probably also some vibration isolation to prevent the motor from shaking the housing too much. And this part is just, there's only one plastic part left. Before I take it off, let's look at how the designers did fluid management up here, because I was mentioning before, like I was curious how they prevented fluid from going down the screw hole. Well, there's also, so there's not only a screw hole through the center of this thing, but there's also a gap on the outside where the rubber grommet was down in there. And there is no type of shaft seal around the outside other than this rubber grommet of the motor. Sorry, this rubber gasket. And it looks like this entire geometry up here on the top was designed to basically be another sort of drip pan, or really just a fluid moat. It's a moat to catch anything that falls on top of the base. It's going to fill up with liquid, and then it's angled so that it will drain out this side and can drain off the base. And that's also the case because this little interface overhangs, and it doesn't seem like fluid could fill up inside this moat and get into the gap on the outside of the interface before it would pour out this little spout on the side. So that's interesting. I mean, that's how they managed the fluid on the top of the base here. Was, again, they didn't completely seal it out. They just created a tortuous path so that fluid would not easily be able to flow up and into the base. Sure, if you put this in the sink and filled it with water, then it seems like water would get in. Maybe the seal on the motor would prevent some of it, but it didn't seem to be compressed enough to really prevent everything. But you shouldn't be putting this entire base into the sink, I guess. All right. Is there anything else in here? Yeah. So speaking of sealing, let's take apart the rest of these components and check out how they sealed up these button interfaces, because these are even more areas that liquid could get into the housing and potentially damage some electronics. Try not to scratch up the table too bad, but this motor's pretty heavy. All right. So there's just a plastic retainer, mounting surface here, unscrew. We'll see if I'll be able to identify where all these screws go at the end. I think my chances are low. I want to put this back together. There might be, oh, I thought there was a hidden screw, but I can actually see it right here. Okay, so here is the screen for the up and down buttons. It's to adjust speed. This thing is on. And okay, so this part isn't actually exposed. There's actually a solid surface over here that I can't get through. Oh, and here's a couple parts that go around the buttons. I'll put these on top of here. So looks like the only thing left. Oh, wow. Okay, that was stuck down a little bit. there is a overmolded rubber border on this little protector screen, and it's the rubber overmold that they compress against the cast housing to create the seal around this LCD screen. So the overmold goes all the way around the border, and that's how they seal up this component. It's interesting. Okay, and the overmold is also, there's a little flexible section in here. Trying to make sure that the camera can see it. There's a little flexible section in here that is the flexible membrane to allow the buttons to be pushed. All the rest of this protector is rigid. So for the three other buttons, these buttons here seem to be more screws falling out. There seem to be several layers. Let's see if I can move some of this other stuff out of the way. Maybe not. It's all connected. There seem to be multiple layers on these buttons. Oh, hey, cool. I was able to just pop this one right off. So there were a couple little snap fingers on these buttons that just snap through what feels to be this little silicone membrane and into a clear plastic housing. So I'll put this back on for a second, and then we'll take this apart. Oh, there's a screw. And it's little flex fingers. All right. Okay, so here we go. Here are the actual three little tactile switches that get pushed when you push these buttons, and also the three LEDs that light up to make the rings glow. And what's cool, there's only one LED for each of these buttons, but they just illuminate it inside these big voids so that the light can just sort of blast out and become diffused just by the amount of space available in these voids. It kind of diffuses itself into these are clear polycarbonate probably, or some other clear plastic housings that the actual retainers for those snaps on the other side. So in order for the light to transmit from these LEDs all the way through to the front surface to illuminate those rings, all the components in between have to be translucent or transparent. All right, I'm going to pop off the buttons. I'm just pulling until they pop off. Those flex fingers. There we go. Now, okay, all the clear plastic button housings just fall out the back pretty easily. So these are the cavities that the LEDs just illuminate into, and then these press up against probably like sort of a translucent silicone in the housing. And it looks like this part, it's multi-purpose. Like it acts as the springs for returning the button, because I think the buttons travel farther than these tactile switches on the board. So in order to get that amount of travel, something's got to push it back up to the surface. And apparently these buttons are unique in where they get placed. So there's all these keying features around each of these buttons, and so I can't just drop this plastic piece into any of the three locations. It's dependent on where it can go. No, that might be it. Okay, cool. So when I push the button, you can see that the silicone piece is actually the spring to return it, even without the tactile switch behind it. Yeah. And then this is a whole nother piece that goes between the spring silicone piece and the cast metal housing. And it looks like there's another layer of rigid clear plastic and another layer of flexible silicone. This actually forms the seal. Okay, so the clear rigid plastic is the illuminated ring. So this is the actual ring that's showing on the front surface, and it's what lights up. So you have to seal. Wow, okay, there's all levels of sealing going on here. There has to be sealing around the ring, which is accomplished by this silicone gasket on here, and then there has to be a seal on the inside of the ring between it and the moving button, and that is accomplished by the same spring piece of silicone. So it gets smashed up against this rigid plastic that is the illuminated ring, and it forms the seal, the fluid seal, to prevent anything from leaking inside the illuminated ring into the interior. So that's really cool. That's interesting little stack up assembly there, where at least this one part right here serves many purposes. It's the spring, it's a seal around each button, and it's probably acting as a light diffuser, because the light has to pass into these clear housings right back here, through this translucent silicone, and then into this clear rigid plastic ring. So the silicone will help diffuse the light from that single LED and make it a nice, consistent blue ring on these buttons. Okay, I think that may cover it for the base itself. Anything else on here that I care about doing? Let's take a look at the bowl, the clear plastic bowl. So I can get some of this out of my way. Oh, heavy motor. Big pile of screws. Okay, so here's the bowl, and let's first look at the feature that we noticed actually pushed that mechanical switch on the base as the motor kill switch. Basically, this finger needs to be down as it is right now in order for the motor to turn on. And I know, because I looked at this before, just there's this clear plastic handle, and if I remove this plunger at the top, you can see it's hard to see, but there's actually a C-shaped piece of plastic that's connected to the spring finger down here. And when I remove this plunger, you can see it move, and meaning once I pull this out, the motor will not be able to run. And then when I push this in, you'll see, yep, there you go, you can see it go up and down. And there are several actions that will do that. If I just remove the whole lid, yep, just the whole lid will do it itself. So that's it's interesting that the mechanical transmission of that force is, directed out of line, down the C-shaped handle, back over to this little switch. But it seems to work well. As far as I can tell, there's only one spring up in here. It seems pretty simple. I don't think I'll take this apart. I'll save that for later. What I really care about is, well, first on this thing, there's a cool little roller mechanism up in here, so that when this plunger gets put in, it translates a sort of rotational motion to a linear motion. Just trying to get it in here. So when this plunger gets put in, it rotates a little roller up this way, which then pushes a rod, which then activates that spring-loaded C-shaped thing on the bowl handle, which will push that motor activation finger. Also seems to be pretty simple. Maybe I'll take this apart last. What I really want to end up getting to is the shaft seal on the bowl itself. It looks like the center part on the lid is just it's like a press fit, or maybe it's adhesive in it, but it's just a metal stop so that some of the shafts, not sharp, actually go in here and just spin as the bearing surface. Pretty simple. All right, so let's look at this shaft. What I think is unique, or maybe it's not unique, but it's more high quality about this Breville food processor, is that there's actually a closed shaft here on the food processor I have at home. And I'm not going to name brands, but it is basically just an open hole so that the blade I drop in can interface directly with the motor. And on more than one occasion, I have filled up the bowl with liquid, which is poured directly down that hole and all over the counter. So this seems to be a much better design. I kind of wish I had this one. Maybe I'll try and get it back together. But it seems to be a better design because you can fill this as much as you want, and theoretically fluid won't go through this center shaft and down onto the top of the base. So let's see how they did that. I mean, it needs to be able to turn fairly easily. It's not free spinning. There's definitely some drag, but it's not too difficult to spin either. What's interesting is something I mentioned earlier was that the designers chose to use these plastic teeth on, this is on the motor. This is that motor interface, which the bowl goes right here. However, they used a metal component on the bowl itself. It seems like if plastic teeth would have been fine for the motor interface, they also would have been fine for here. So maybe we'll find out a good reason for why they did that. All right, there's just a hex nut in here I'm going to take off. I sized this ahead of time so I have the right size socket. Okay, so the hex nut, it has some of that like nylon locking stuff inside it, probably to prevent it from vibrating off while, over the years of use. Oh, okay, it just popped right out. This is that metal interface. And there was a washer in there with that hex nut. Just fell out. There it is. There's a shaft that's passing through the bowl, and then this metal part with teeth has, it's just a shaft with two flats on it. So you know what? That's probably the reason they decided to go with the metal part here, is because even though plastic big teeth could have taken the torque, these little features that connect the shaft through the bowl probably would not survive the torque necessary if they were in plastic. So they may have needed a metal part down here just so they could transmit the torque from the base up through the bowl and up to the spinning shaft up inside of here. All right, so this shaft's just gonna fall right out. Ready? Okay, there are a couple seals. I see there's like a fiber washer and another washer up in here. Set those off to the side. These seem to be sort of friction reduction elements in between this metal interface and what looks to be a bronze bushing that is actually held securely into this plastic housing. So this bronze bushing is rigidly affixed inside of this plastic housing. I'll try and take it out in a second. And then here is the shaft that goes on the inside, and it interfaces directly with the teeth that go into the motor interface over here. So this is in the bowl. Here's the base. That's how it transmits the torque up to it. So as far as the sealing design goes, there are two obvious seals. There's one on the center shaft. Yeah, see it. There's one on the center shaft here. It's like a basic O-ring. It actually looks like kind of like a flanged sort of seal that doesn't require a whole lot of compression to make a good seal. And it looks like a duplicate of the same sort of seal gasket up here. So it doesn't require a whole lot of compressive force to make contact with this little seal flange and create a good liquid seal. And it looks like they did both of these just as sort of redundancy. They seal up the same hole in here. Yeah. So there's no reason to have two on here except for redundancy. That big one spins on the outer surface of the top of this bronze bushing, and this part right here isn't bronze, but I can see it down in here. And then that inner seal spins just a little bit closer to that center hole. Let's see. So it looks like this thing, something that they wanted to avoid was this actually spinning inside of the clear housing. So there are 3 teeth to really key this thing in and prevent it from spinning. I'll try and get it out. Take a look. There's just a retaining ring up here. Shoot this into my face. Okay, got it. Retaining ring right there. And okay, there was just a little washer with that retaining ring. And it looks like there's like a rubber, it's just like a big rubber seal that that this bronze bushing is pressed into. Oh, okay, yeah. There we go. So there was a little rubber washer on the back side that was right underneath this washer. And then this guy, the bronze bushing, just fell out the inside, and there is this rubber seal that goes with it. So this is like a custom designed and molded rubber piece that has 3 little teeth so that the little keying teeth on this bronze bushing can fit into it, then fit into the same features on this canister and prevent this from rotating inside of the clear bowl. This part, yeah, it looks like this is just an like a bronze bushing, or maybe it's brass, with this plastic housing overmolded on top of it. And there are probably some torque carrying features up in there, either some like a spline or some knurling or something, so that when they overmolded this plastic on top of the brass, it it would really grab on tightly and it could transmit the torque between these two parts here. Let's see. I think that's really it. Here's another overmolded part, and there's another seal O-ring on this part. This is that shaft that went into the bowl. This metal or the steel shaft looks like it's overmolded with these plastic teeth. So, I was talking about plastic versus metal teeth. They have metal teeth on the bottom of the shaft, and they went back to plastic teeth on the top that are close to the same size. So that sort of does lend some credit to the argument that they chose a metal component down here simply to withstand the torque at this interface and not necessarily the teeth itself. Let's see, I covered everything. I think so. Actually, the last thing I had jotted down on my outline, so I didn't forget anything I wanted to talk about, was the choice of them using a bushing here instead of a bearing. And there might be several reasons that they did that. One, you can get a much longer length that the shaft is engaged with, so it will prevent this from wobbling back and forth as much. And it's also just less little nooks and crannies for fluid to get embedded in and just become sort of a mess. So it's probably less sensitive to debris over time. Well, I think that's it for the teardown. This was interesting for me. I covered pretty much everything I wanted to. Just wanted to thank everyone for watching, and we'll do a full write-up of this, which you can find at m3design.com, and we'll be doing more of these in the future. Thanks for watching.